these are the base cases. Once this is hit, the memo will be populated with 0, 1, and then fib of 2 is calculated based on these cached values, which will be 1, so it will be cached, and then fib of 2 will not be recalculated. It will use this cached value. I'll show that in dotted line so that it's not confusing. It's not a branch of a subtree. The dotted line denotes the caching. So fib of 3 is also uses the cached value. This is the base case. So if you see the code path, at the maximum, each node will have 2 children. That's n plus n. So if you look at this code path, there might be a maximum of 2n. So because we are caching, we are not generating any more nodes. So this is really good. So we are reducing from an exponential to an order of, if we ignore the non-dominant term, the constant 2, so this gives us an order of n time complexity. So this is the entire code and the code path. Also, in the previous videos, I talked about how we're unifying philosophy of judgment and philosophy of reason and understanding with math and problem solving to explore patterns in groceries. And I mentioned modality of judgment and modality of categories. Modality of judgment, which includes esoteric, problematic, and apodictic. And modality of categories are necessity, contingency, existence, non-existence, possibility, and impossibility. We are also going to consider the quantity of judgment and the quality of quantity of categories. So those are quantity, quantity of judgment, universal, singular, and particular, and quantity of categories. Unity, totality, and plurality. We will explore these ideas, and we will also see that in our future videos further optimization. So this is a top-down memoization. It's a dynamic programming. In the bottom up, in the next videos, we're going to see that we're going to cache the base cases upfront at the start, at the beginning. And then in our next videos, we'll completely eliminate the space, and we'll just use variables. And in a future video after that, we will see how we can further optimize from an order of n to an order of log n. It's going to be very interesting. And some hypothesis of, can we really do Fibonacci in a constant time? I somehow feel we can do. We'll talk about the hypothesis as well. Yeah, thank you so much. for watching my videos.